Well, let's get started because we have a lot of content and we want to make sure you're all able to see it. My name is Erica, I'm from Databricks, and I have Richard here with me. I cannot tell you how happy we are to be here in person, and we're very grateful you're here to see this session. This session is an overview of the Lakehouse. We're going to share a little bit of what our customers are doing. We have an amazing demo. It's the best way to showcase the products. And we want to share a little bit of the reasons why our customers are building applications on the Lakehouse. So just to get started, the world is changing, and there's never been a better time to be a data team. There's all these different applications that every industry is building. It really doesn't matter which industry. Everyone is trying to build solutions with lots of data to help predict the future. And really what Databricks' mission is to help everyone, every data team, to build the best solutions on the most wonderful architecture. So this morning you heard Ali talk about the Lakehouse. He talked about how and why we built the Lakehouse. And there are three things I want you to remember. One is, as you're building solutions, really the promise of the Lakehouse is to make that simple architectures and really to make it really easy to build solutions on the Lakehouse. The second thing is that you're able to create these solutions on any cloud. The Databricks is multi-cloud, and it really gives you a lot of flexibility and choices. Lastly, it's a fully open platform. It's built on open source and open standards, and that helps you integrate with all the different ecosystem tools. So customers love and trust Databricks. When I think about this, it's really not just enterprises, but startups across every different industry that is building solutions on the Lakehouse. In fact, over 50% of the F500 are already building solutions on the Lakehouse. And this week, we have a lot of our customers showcasing how they're building solutions on the Lakehouse. There's just so many great examples. It's hard to pick something, but I decided to pick this example because it's close to my heart. HSBC has built an amazing application. It's called PayMe. It's a mobile app. And there are two things that they've done really well with Databricks support. One is they've been able to create a unified solution across the platform. So they use machine learning, data engineering. And also, they've been able to take both batch and streaming data and take and process real-time data, millions of records of data, to give a really great experience to their customers. In fact, they've seen significant impact in customer engagement, and they've seen a lot of reduced time and processing times. And by the way, HSBC it's here today at the event. They have an amazing session on cybersecurity. There's a lot of our other customers who are here to showcase applications. And so when we were planning how to do this session, we were thinking, what's the best way to present the Lakehouse? And honestly, the best way is to see the product. So I have Richard here with me. He's going to be doing a demo. It's an amazing end-to-end demo. So Richard, the stage is yours now.
Thanks. Thanks, Erica. Hey, everyone. My name's Richard. I'm a product manager here at Databricks, and my goal here is to show you everything in the Lakehouse platform live in the next 20 minutes. So wish me luck. The subject area for today's demo is Divvy Bikes. I live in Chicago. It's a rideshare system. You just swipe your credit card and you can rent a bike for the day. All of the stations that these guys sit in are connected like IoT devices, so you can ping them via a REST API and get the real-time station status of how many bikes and how many docks are available. So the story is my business, I work for Divvy, they've asked me to build them two reports. They want a real-time report that shows the station status of any Divvy bike station anywhere in Chicago right now or for any moment in the past. And they also want to know a forecast of how many bikes are likely to be available in the next 10 hours. Right? So that, like remembering back to when Ali presented today, it's that what happened, that kind of left side of the maturity curve, and the right side of what will happen. So we're going to try and answer all these questions with the Lakehouse platform. So first we're going to start with ingesting data from those REST APIs. We're going to call those REST APIs and land those files in our cloud storage. Then we're going to build a streaming data pipeline using Delta Live tables to expose that data for analytics and for data warehousing and business intelligence. On top of that pipeline, we're going to build a business intelligence application that's running on Photon Data Warehouse. And to answer the forecast question, we're going to build a machine learning model that is going to enable us to forecast availability, write those predictions back into the data warehouse so we can build a nice report on top of that as well. And we're going to do that all on the Lakehouse platform, one platform for all these different use cases. So I'm not sure how many in the audience have seen Databricks before. I'm assuming most of you have, more or less, but I'm going to go through some 101 stuff as well as some of the more advanced features. But the first stage of this demo is data engineering. It's to build this real-time pipeline so I can build my analytics and my machine learning models on top of it. So I'm now a data engineer, and I'm in this data engineering space. Over on the left here, I have access to my own personal workspace with my own notebooks and code and experiments and so on. They're all nicely organized in a little folder for me here. This is everything for this demo in the Divi Bikes folder. All of my code I can sync up with a code repository if I want to do like true CI/CD. I've not done that for this demo. We can explore our data here. I'll come back to this. If I click on compute here, you can see I've provisioned 3 clusters for the purpose of this demo. They're all optimized in different ways. My ML cluster is built for running machine learning models and building machine learning models. And I've got a Photon cluster to do some of that hardcore ETL crunching and a single job node just to do my ingest jobs. If I go into workflows is really the orchestration area for the Lakehouse. So everything you do that needs orchestrating and scheduling, you come to workflows and set that up. I have 2 ingest jobs that are running. You can see that these are scheduled to run every minute and every hour. And all they're doing is pinging those REST APIs and getting the response and dropping that as a JSON file into our ADLS cloud data lake. I'm not going to show you the code for those. It's just written in Python. It's pretty boring. But all I did was write those in a notebook and then schedule them through here into these jobs. And you can see that these have actually been running for a while. I actually kicked these off in January this year. So I've collected billions and billions of rows of data across millions of JSON files. But you can really see for any of these tasks in this particular job exactly what's going on if you need some monitoring. And as I said, it's more than just a single job. This is actually a job that has multiple tasks. I can add lots of different task types here and create really sophisticated DAGs. So you don't need to use Airflow if you don't want to orchestrate the Lakehouse. And we're really adding tons and tons of different types of tasks here, not just Spark. We just actually added DBT and DB-SQL dashboards as task types as well. I don't have them on my particular instance of Databricks here. So that's the ingest side. They're jobs running, collecting data in cloud storage. The next thing I want to do is actually write an ETL job to pick all that data out of cloud storage, get it into our Delta Lake, and get it cleaned up and ready for analytics. So to do that, I actually use Delta Live tables. So I'm not sure if you're aware of Delta Live tables. We recently GA'd it. It's a declarative language for building data pipelines. And this is an example of the notebook I've created. This is written in SQL. If you're into Python, if that's your thing, you can write Delta Live table script in Python too. But I am not a data engineer at all. I'm just a SQL guy. So SQL works for me. And you can see what it does here is a couple things. I've created a streaming live table. That means it will continuously accept data as soon as it's available and stream it into this table. It's just saying select star from cloud files and points to the file structure in our ADLS data lake where it's collecting all those JSON files. Cloud files actually invokes Databricks Autoloader, which is kind of a streaming pattern optimized for incremental loading. So it knows all the files it's already processed. You don't have to manage state. And you can also see that we just tell Autoloader that it's JSON and tell it to automatically infer the schema for us, which is super cool, especially with things like JSON. So it will figure out what the rows and columns are in the data for us. So that data will then stream into this Delta table, raw station status. And from that table, I then do a second step in my ETL. Oops. So I'm kind of following the medallion architecture a little bit here. I'm creating my, I guess this is my silver level table called clean station status. And it basically is selecting from the raw table here. And you'll also notice that I've added a couple of data quality constraints. So as data streams into this table, it's going to check for valid station IDs and drop the row if they're missing or they're not valid. It's also going to do some kind of looking for old records versus new records here. And you can set up all of these data quality constraints, and DLT or Delta Live Tables will manage this all for you. I also, just as for good metadata best practices and discoverability, I've added some comments, and I've tagged this table as a silver table as well. And then we have the same concept with our other data streams coming in through our ingest. I'm just creating a raw weather information table here and then cleaning it up and streaming it into a cleaned up version. And then I've got some kind of dimensional information, my station information here, putting it into a raw table, exploding that JSON, and then actually merging it into my clean table. So this is upserting versus just appending the whole time. So that's all I've had to do to write this ETL is know SQL and know these little subtle variations of the SQL language for Delta Live Tables. When I want to operationalize that, I come back into Workflows, click on Delta Live Tables, and then just create a new Delta Live Table pipeline and point it to that notebook. It's as simple as that. I already did that, and this is my Delta Live Tables pipeline. So you can see this is running. It automatically knows the DAG, the flow of the data, just by looking at that SQL or looking at that Python that was in that script. So I can actually see the data flowing in real time here. And this is a continuous pipeline, so I'm not shutting it down to do batch and spinning it up every hour. This is just an always-on cluster that's continuously loading. Delta Live Tables also runs in batch mode if your use case you can get away with batch, but this is a real-time monitoring use case, so I need a continuous pipeline here. So that's all I've had to do. As I mentioned, I kicked this thing off in January, and this thing just runs. It's fallen over a bunch of times. It recovers itself. It auto-scales. It optimizes all of the data, so you don't need to worry about performance tuning. As I said, I've got multi-billion row tables here, and I've literally haven't written any kind of optimization to keep query going. It's just, it basically handles all of that operational tooling for you, so you can just focus as a data engineer on SQL. So I've got my 3 tables now, and the next thing I want to do is do some data warehousing or build some analytics on those tables. So I'm going to go into my second UI inside Databricks, which is DB-SQL. And this is where I build queries, build dashboards, share that information, and so on. But the first thing I want to do as a SQL analyst, so I'm now kind of changing my persona to be more of a SQL analyst or an analyst engineer, I want to spin up a data warehouse. So I've already built one here, which is my primary SQL endpoint. That's actually a Photon cluster running now, which you've all heard about. We're breaking all those world records with query performance and so on. And this is just an endpoint that all my queries will now run on. And you can connect your favorite BI tools to those endpoints if you want to use Tableau or something like that as well. I'm actually going to use the native visualization capabilities in Databricks to do this next part. So as a SQL analyst, the first thing I want to do is look for some data. My business has asked me to write some reports. So I got to find the right tables. So I'm going to click into Data Explorer. And now I can see all of my tables in my workspace. And you'll notice I can see all of the tables in everybody else's workspace as well. So this is actually, I'm using Unity Catalog, which is that single governance model for your Databricks workspace and all of the Databricks workspaces that you can access. You have a single way to govern all of the data, all of your models, your files through Unity Catalog. I'm actually going to search for the word Divi now because I don't know where any of the data is. And you can see that it's found those tables that we created with DLT. I'm going to click on Clean Station Status because I know that's the table I want to go after to answer a quick query here. And you can see the schema. You can look at sample data here. You can look at some of the metadata behind the table. So, quality equals silver. That's what I set up in that DLT script. You can look at any permissions. As an analyst, it might be my DBA that does all the permissioning here. But I can actually set my grant statements here through the UI, or I can just use standard ANSI SQL to do all of my permissions on rows and columns and tables and so on. If you're familiar with grants in SQL, you already know how to do this. This is all running in Delta Lake, so obviously I've got access to all of the history, that audit trail about the table, like everything that's happened, so I can do all of the time travel on my Delta table if I want. And then finally, we also have lineage. We capture the table and column level lineage here. So I can see that this particular table upstream came from this raw station status table. And then downstream, I have an aggregate table that's populated from this clean station status. And it's actually a lot easier to see if you look at this lineage graph here. So here's this table I'm looking at. Here's everything upstream that contributes to it, and here's everything downstream that it contributes to. And you can kind of click around and explore all of the lineage between your tables and your columns, which is really important for just that auditability and explainability for all of your analytics. Okay, so what I want to do now is create a quick query on that table. You see, like, Databricks has already kind of suggested a little select star for me, but I actually want to do an average. Average here. So I'm going to click average, and then I want the number of bikes available. And let's say I want to group that by something like station status. So there we go. I don't like typing SQL statements in front of a live audience, but there you go. So this is my query, and then I can just run this. So it's just like, for those of you familiar with query editors, right, there's no surprises here. This is how you build up your queries and test them. Once you've got your results back, you can kind of create pretty visualizations on those results. There's a variety of different visual types here, so I'll pick a pie chart, everybody's favorite visualization. You get the idea. So then I can take these visuals and add them to dashboards. So rather than doing that, I actually built one earlier, which is a really cool one called Divi Bike Realtime Monitoring. So I basically took that process that I just walked you through to build out this dashboard. So here we are. This is real time. So this is right now in Chicago. They're 2 hours ahead of us. And you can see the number of bikes and docks available across all the stations. This is the average temperature across all of those stations. I can slice and dice this by any particular station if I want to. But this is super actionable information, right? It's actually real time. But I can also go back in time. So let's go back to February. I said I've been running this since January. I know, living in Chicago, that the 2nd of February was a miserable day. It was actually one of our biggest snowstorms that we had in Chicago. So I can just change my time perspective there and go back in time and look at what was going on at any particular hour, minute, on any day, anywhere in the past. So you can see kind of all of the metrics here. Okay, so that's kind of the data warehousing and business intelligence piece. I've showed you everything that's native to the Lakehouse, but we also have Partner Connect here. And if your ETL tool of choice or ingestion tool of choice is Fivetran or dbt, you can just come in here and pick it. and you'll actually can set up the connection to Databricks right from this UI. So for those of you that want to use your favorite tools and just use Databricks as that piece of the modern data stack, you can absolutely do that. All right, so take a breath. All of the stuff I've showed you so far is like real-time now and historical information. The next part of the demo is to go into the future. And to do that, we're going to click into our machine learning part of the UI. Now, the ML UI here is basically gives me everything I need to do my exploratory data analysis, build models, do feature engineering, build feature stores, deploy models, monitor and manage them in production. So I have full support for the full ML lifecycle inside this particular UI. I can start here with looking at some experiments. So this is like models that have been created and have been running as experiments and registered into MLflow. I'm not going to build a model from scratch. That would be crazy. I'm going to actually use our AutoML capability to spin up a quick baseline model. So as a data scientist, I can get a sense of whether it's accurate or not, and then customize that model before I deploy it. So to do AutoML, it's super easy. I pick my ML cluster. I pick my problem type. So I want to forecast data. I pick my training data set. So I have a training data set called Ag Top Stations and Weather for the last 30 days. I'm going to pick that. And I'm going to pick something to predict. So I actually want to predict the average number of bikes available for the next 10 hours. So I'm going to tell it average bikes available. I'm going to tell it what the timestamp column is, because this is a time series forecasting, so it needs a timestamp. And then I'm going to tell it I also want it to forecast for each station, not just do a general forecast for all stations, but actually have a multi-series forecast here. And I'm going to set my horizon here to 10 hours. And I could write the results out to a delta table if I wanted, but I'm not going to do that, and I'll just click Start. So that's all I've had to do to set up an AutoML experiment that Databricks will now start running. It'll start testing different models against my training data. Each model, it'll test different hyperparameter settings. And after a while, it's going to test a ton of different models, and it's going to tell me which one it thinks is the best model. And as it does that, they're going to start to appear down here at the bottom. We're not going to wait for that. So we're going to go to one that actually ran earlier on, just before this session. And you can see this is my AutoML run now that's actually completed. And you can see I have a bunch of different models here. This one, it's organized by the error here. So this one at the top is like what it considers the winning model. Now, one of the cool things with Databricks AutoML is that we have this concept of glass box models. So there's no mysterious logic here or algorithms or pre-processing that we don't allow the data scientists to look at and change. So I can open up an automatically generated notebook for that top model. Now, as a data scientist, I can come in here and just see everything that AutoML did. This is how it loaded the data. This is some of the pre-processing that it did. This is some of the default hyperparameters that it's tried for this model. And this is actually here where it runs and trains the model. I hope you're drinking all this in as I fly through it at 50 miles an hour. And then, as well as running and training the model, it actually does a little bit of explainability. Here are some of the initial results. It's kind of trying to marry actuals versus predicted, just so you can get a sense of, is this a good model? Does it look accurate? What are the distributions in my data set look like? And then this is the actual results, the predictions that it's running. So that's full access to that notebook. And you can change it and do whatever you want to it. Let's go back to the experiment. What I would want to do in reality now is if I like that model, and let's say I've customized it, I want to put it live. I want to deploy it. And to do that, it's pretty straightforward. I just click on the model. And the first thing I need to do is register it into the MLflow registry. So I just click Register Model. I'm going to say I'm going to create a new model here. call it dias123 or 1223 and register that. So that's now going to package up this model with all of its dependencies and put it in the MLflow registry. Then I can come down here and look at my models, and here it is. I've got 3 in the registry. Think of these as like staged, ready for deployment. So if I click on that model, here it is. This is where I can do all of that MLOps, governance and controlled workflows. You don't want anybody just putting models into production willy-nilly. That's crazy. So you can do all of that version control, have approval workflows at this particular UI. But I'm going to use this model for inference. You just click right there, and you can see that I can either pick batch inference, or I can put it, expose it via a REST API onto a Databricks node, so it can do real-time model serving as well. But I'm going to pick batch inference here and set this thing up. I'll tell it which training data set to use. So it is this one. And I'm going to say, use that for batch inference. So that's now deployed, and what Databricks gives me is another automatically generated notebook that is basically all my inference code. Now, to automate this, all I do is schedule that notebook, again, via a job in here, which is exactly what I did here, right? I'm refreshing my training data set, and then I'm running that notebook to score the new data after the training data set has been refreshed. And that's running every hour on a schedule. So every hour, I get the next 10 hours of Divvy bike availability in Chicago. And that's what's been running, right? So when it makes predictions, those predictions then get written back into Delta Lake, so I can do my last report, which the business asked me to do, which is to build my hourly forecast here. So this is kind of where I'm ending the demo. This is like really cool. So this now, for a few, I just picked the top 5 stations. These are the expected number of bikes for the next 10 hours at those stations. So really actionable information if you work for Divvy and you need to figure out where to put all of your bikes and so on. Okay, so that's the end-to-end demo. If you want a personal version of that we can go slower and ask questions, please come grab me after the session. But for now, I'm going to hand this back to Erica just to finish off some of the last slides.
Thank you, Richard. Honestly, after that fun demo, it's hard to go back to slides. But I actually want to tell you why our customers are building applications on the Lakehouse. And the very first thing is they trust really the data reliability and performance. The second thing is governance is incredibly important as you build solutions, and we have an amazing product. And then lastly, as you saw on the demo that Richard was showcasing, you can really build a solution that works across all your workloads. So when it comes to data reliability and performance, Delta Lake is the foundation of the platform. It's the most open and advanced industry standard for open storage. And we've seen incredible success with our customers because of the performance and reliability it provides. And we also have Photon, so we were talking about the benchmarks. So this is a state-of-the-art vectorized engine. It works with Python and any other language, but also Spark and all the different APIs. So definitely this gives a big differentiation to our customers that are building solutions on the Lakehouse. And we've heard a lot from them, and 3 things that they say they like we're building on the Lakehouse is scale, speed, cost savings, and of course also reliability. Governance. So when you're building a solution, you want to make sure that it's secure and also that you're able to build a solution that works across all your data assets and across all your different workloads. And for this, we have built Unity Catalog. And today we announced that the GA is coming soon. So when you're working with Unity Catalog, there are a few things that are benefits to our customers. One, like I said, is a centralized governance for all your data assets across all your workloads. Also, it has data search and discovery. You can use data lineage, And finally, it integrates really well with all your ecosystem, so you have the flexibility to integrate with other partners. And last, the one thing I wanted to share, and I think this is just very powerful, and it's one of the most interesting things that we have with the Lakehouse platform is you're able to really take your solutions across all the different workloads. From taking historic data, just as you saw in the demo, all the way to predicting the future with AI and machine learning. And there's several platforms and technologies that are really powering these solutions. When it comes to data engineering, we have the most powerful, complete end-to-end platform for data engineering. You can ingest, transform, orchestrate your data, and have observability and monitoring. And all that is powered with great products like Delta Live Tables that we used GA'd a few months ago, and Databricks workflows. And all of these allows both for reliable orchestration on the Lakehouse, and you can also manage your infrastructure very well and take modern software engineering best practices for ETL. This is also a close product to me, data warehousing. We have the most advanced and the most powerful data warehousing solution in the market. And there are 5 things that our customers like when they're working with Databricks SQL. So you heard Ali this morning talk about best price performance. And really, this is a differentiator. You're saving money, and this is all about cost. But also, we have serverless. So with that, you don't have to worry about infrastructure. You can always work with an application that takes care of compute in an elastic and in a way that scales. Also, something that is very interesting about Databricks SQL is you can integrate it with the ecosystem. There's multiple partner solutions that you can integrate into your solution, and you can get powerful visualizations, for example, with Power BI. Also, something very important is you get out-of-the-box integration with machine learning and prediction for the future. We also talked today about how we're investing on data streaming. And really, there's a lot of applications that are built both on batch and streaming with the Lakehouse. One thing that is very interesting about data streaming is there's also a lot of good integration with your favorite tools of choice. There's a lot of optimization real time on costs. And there's a lot of integration with other tools. But one thing that is very peculiar about streaming is we built it in a way that it's accessible for everyone. So really, it's all about democratizing data streaming and making sure that regardless of your skills and regardless of what tools you use, you're able to build streaming solutions. Finally, data science and machine learning. So you're able to create applications that predict the future and that take care of things like DevOps, MLOps, Model Ops. It's all integrated and built in the platform. So I have a little over 1 minute, so I'll tell you something. It's really hard to unpack all these products and all these capabilities in a 35-minute session, but I want you to take a picture of this slide. We highly recommend you attend these sessions. They will go deeper into each one of these workloads, and they will showcase all the different products. And if you're at home watching online, please take a screenshot. It's really worth to spend some time looking at these sessions. I'll give you a minute here. And then I have another great surprise. So something else that we did is we decided it would be amazing to have a guide created for all the data teams. It's a fully comprehensive guide on how to explore the Lakehouse. It goes across everything I just shared in much detail. And it shows a set of good examples on how you can build your awesome solutions. So that's it. We can't wait to see what you build. We want to thank you for your time. I have 30 seconds left. Thank you for your time, and I really hope you enjoy the rest of the summit.